Today, we're going to talk about linear versus nonlinear functions. In front of you on your desk, you should have this graphic organizer. Please take notes on this graphic organizer throughout the PlayPosit. Pay attention to the blanks that you will need to fill in, as I will not be filling this out for you in the PlayPosit. First, we're going to look at seeing how we can tell if a table is linear or nonlinear. To understand whether a table is linear or nonlinear, we need to look for a constant rate of change. The word constant means that something is the same. So first we're going to look at our y values, then we will look at our x values. So let's start with function a. I can see that my y value is increasing by positive 3, as 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and 11 plus 3 is 14. So my y's are increasing at a constant rate. Now I need to check my x values. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. So my x values are also changing at a constant rate. If both my x and y values are changing at a constant rate, my table is linear. Now let's look at function b. In function b, if I look at my y values, I see that from 3 to 4 is an increase of 1. From 4 to 7 is an increase of 3. From 7 to 12 is an increase of 5. And from 12 to 19 is an increase of 7. While there is a pattern, 1, 3, 5, 7, continuing probably 9, 11, 13, and so on, this is not a constant rate of change. If my y's are not changing at a constant rate, there's no need to check my x values because this is going to be nonlinear, as both the x's and y's must change at a constant rate to be linear. Now let's look at function c. On function c, I can see from 1 to 3 is plus 2, 3 to 9 is plus 6, so I can go ahead and stop because, again, I have a nonlinear function. So to summarize, when looking at a table, it is linear if it has a constant rate of change, meaning the y's are changing at a constant amount, the x's are changing at a constant amount. My function is nonlinear if there is not a constant rate of change. Now let's look at graphs. When we are looking at a graph, to know whether it is linear or nonlinear, all we have to do is look at the word linear. Right in the word linear is the word line. Linear means line. So if a graph makes a straight line, it's a linear function. If a graph does not make a straight line, it is nonlinear or not a line. So if we look on the linear side, I have a straight line and another straight line. These are linear functions. The only exception to the rule is a vertical line. Remember that vertical lines are not a function at all. They're not a linear function and they're not a nonlinear function. They're just not a function. On the right side are my nonlinear functions. Nonlinear functions are any graphs that do not make a straight line. Lastly, we will discuss how to tell if equations are linear and nonlinear. Equations are a little tougher. There is no single rule to memorize about what makes an equation linear versus nonlinear. Instead, we can focus at looking at lots of examples and recognizing patterns. And remember, a linear function makes a straight line when it is graphed. Another tip is that we only work with linear equations in the 8th grade, so look for familiar equation types. For the purposes of today, here are some ways that you can look to see if an equation is nonlinear versus linear. For an equation to be linear, the variables cannot contain exponents. So there can be no exponents in my equation. The variables cannot be under a radical. The variables cannot be inside absolute value. And the variables cannot be in the denominator. These different options make something nonlinear. So as long as we have an equation that's not containing anything in items 1 through 4, it may be a linear equation. Another tip is that linear equations often, but not always, begin with y equals. All of the equation types listed that I've pointed the arrow to here are linear. Notice that none of these contain exponents, none of these contain a radical, and none of these contain a variable in the denominator of a fraction. Now let's look at some examples for knowing that an equation is nonlinear. An equation is nonlinear if it does include exponents, if it does have variables under the radical, if it does have a variable in absolute value, or if it does have a variable in the denominator. So again, if we look at the examples over here to the left, an example like y equals 3x squared would not be linear because it includes an exponent. Or y equals x to the fourth, again, is nonlinear because it includes an exponent. A number raised to the power of x. If our exponent is a variable, again, seeing an exponent should be an automatic clue, nonlinear. Y equals the square root of x plus 5. No square root symbols, it cannot have a radical. Or a variable in the denominator, such as y equals 4 over x. If we can look for these common patterns, this can help us understand whether an equation is linear or nonlinear. Again, these are just a few common examples. Remember, any equation that does not create a straight line when graphed is a nonlinear function. To finish up our play posit today, you will be completing a play posit check. For each function, you will choose linear, nonlinear, or not a function. You may rewind at any time to go back and look over the information. Please use your graphic organizer to help you through this assignment. If you have any questions, please raise your hand and I will be glad to come over and assist you.